Okay, so we're going to be continuing with the synthetic division, which plays a big role for us here with polynomials. And what I'm gonna be talking about next is gonna have its own name, the factor theorem, but it's almost the same thing, but a little bit of a difference. Just bear with me on this. Be careful. All right. So now it's gonna have its own name, the factor theorem. The factor theorem, but it's almost going to be the same thing. Hold on. Factor theorem. Okay, so now here's the question. Problem one, we're given a polynomial, very similar to the previous questions. We're going to be using synthetic division. We're going to be using synthetic division again. Using synthetic division. So it's really important to get synthetic division down. Synthetic division. All right, here's our polynomial. F of x is equal to x4 minus x3 minus 11x squared plus 11x plus 12. Okay, now the question is, here's how the question is phrased. Watch how the question is phrased. Be careful for a test or for homework. Here's how the question is: x minus 3 a factor of this polynomial? Which polynomial? Obviously this one. X minus 3, is it a factor or not? The way to be a factor is that when it's going to be a piece of a factor is a piece of a larger picture, and if you divide by this number, you're going to get a 0. It's going to turn out to be equal 0. I'm sorry. If it's a factor, it'll be a one whole piece of the original. So let me show you how this works. Okay, so we're going to use synthetic division exactly over here, but just be very, very careful. Put a 1 here, and then a -1, and then a -11, and then an 11, positive 11, and then a positive 12, and put your L. Now you'd be tempted to put a -3 in the upper left-hand corner. Don't do that. And if you ask a question, is x minus 3 a factor? Is x minus 3 a factor? Do not put a -3 here. Put a positive 3. And if the remainder is 0, you say, I can just put the number 0. Is remainder is 0, then yes, it's a factor. Then yes, it's a factor. It's a factor. And if not, and if remainder is not equal 0, let me put equal here. Remainder is equal to 0. If the remainder is not equal to 0, then no, it's not a factor. Then no, it's not a factor. That is the rule. So we have to just go check out one thing. Are we going to get a remainder 0 over here or not? Is this going to be 0 or not? The remainder. I'm talking about the remainder. This slot right over here. Okay, let's see. Bring down the 1. 3 times 1 is 3. Minus 1 and 3 is going to be positive 2. 3 times 2 is 6. Minus 11 and 6 is minus 5. 3 times -5 is -15. 11 and -5 is -4. 3 times -4 is -12. And this was a 12 up here. This is a 12. 12, -12, 0. Yes, the remainder is 0. So the answer is yes. X minus 3 is a factor of the polynomial, of this polynomial. Which polynomial? This polynomial. And that's it. That's how the factor theorem. That's how the factor theorem is going to work for us to test if something is a factor of a polynomial or not. If this would have said 1 or 2 or 3 or minus 1 or minus 2 or minus 3, it would have said anything but 0, then you would not answer yes, you would answer no. If the remainder is 0, then yes, it's a factor. If the remainder is not 0, if it would have been a negative 1 or a negative 2 or a 1 or a 2, anything but 0, then it is not equal to 0, and therefore it's not a factor. Right? But ours was a 0, and therefore the answer was yes. Okay, that ends this video.